What could a falling leaf possibly have in common with a power grid? Or get this, how does the skin you shed every single day connect to building a satellite? Well, today we're going to dive into this one single, really powerful idea that links the natural world to our most advanced tech. And it all comes down to a fundamental principle of survival: knowing when to let go. I mean, you've seen it every single autumn, right? The trees, they explode with color, and then they're bare. It's so easy to look at that and think, oh, it's a sign of decay or maybe weakness. But it's actually the exact opposite. This is not some passive surrender to winter. No, this is a deliberate, super carefully planned strategy for survival. And believe it or not, this strategy has a name. It's called abscission. It's basically the controlled, pre-programmed shedding of a part of the plant. You can kind of think of it like self-pruning. The tree is making this calculated decision, right? It's cutting its losses to save up resources, making sure the main trunk and branches can make it through the tough winter ahead. And the process itself? It's incredibly precise. So the tree literally builds this specialized area called an abscission zone, right at the base of the leaf. It's like a pre-planned weak point. And you can see here, it's made of two layers. One is designed to be weak and just break away. The other layer actually expands to push the leaf off, and this creates a super clean break, and it instantly seals the wound behind it. It's just a total masterpiece of natural engineering. Okay, so here's the really crucial point. This isn't just about trees. This whole blueprint, letting go of one part to save the whole thing, it's absolutely fundamental to life. It's a core principle for being resilient, for renewal. And it happens, believe it or not, a lot closer to home than you might think. In fact, your body is doing it right now. The process is called desquamation, and it's just the invisible, super orderly shedding of the top layer of your skin cells. And this is not just waste. It's actually how our skin stays in one piece, how it removes damaged cells, and makes sure it's a strong protective barrier against, well, everything. We literally shed to stay healthy. All right, let's really get into this, because this is where things get fascinating. This is where a simple biological process turns into a high-stakes engineering solution. We humans, we observed this idea of strategic shedding, and we engineered it right into the critical systems that power our entire modern world. In the world of power grids, it's called prioritized load shedding. So imagine a scenario where the demand for electricity is just dangerously high, way more than the grid can supply. The whole system is at risk of a total collapse. What do the engineers do? Well, they don't just let it all crash and burn. Instead, they intentionally disconnect certain, less critical parts of the network to save the most important stuff. And this just illustrates the parallel so brilliantly. I mean, look, on one side, you've got the tree's abscission zone, that specially designed weak point that lets the leaf go cleanly. And on the other side, you've got a power grid, where certain circuits are literally designed to be cut off. In both cases, the logic is exactly the same. Sacrifice one part to save the entire system. And this paper from Eaton puts it really clearly. This isn't plan A. It's a critical backup plan. It's what you do when the system just can't balance itself anymore. Shutting the load becomes the last and best defense against a total, catastrophic system-wide failure. It's like the power grid's survival instinct kicking in. Okay, so that's one side of the story, shedding to survive. But now, we're going to flip this entire idea completely on its head. We've just talked all about how shedding ensures survival. But what about environments where the exact opposite is true? Where shedding even one single microscopic particle means total disaster. Well, welcome to the world of clean rooms. In places like aerospace, pharmaceuticals, life sciences, microelectronics, the goal is not shedding. It is total, absolute containment. You can think of these places as fortresses, built to keep the outside world out. And the enemy? It's any tiny particle that just doesn't belong there. So let's try to put this in a perspective, okay? Your typical city air might have millions of particles in a single cubic meter. But an ISO Class 7 clean room, which is pretty standard for making pharmaceuticals, allows a maximum of 352,000 particles of a certain size in that same space. I mean, that is incredibly clean. But for some jobs, it's nowhere near clean enough. Now get ready for this leap. An ISO Class 5 cleanroom. This is the kind of thing you need to assemble super-sensitive satellite sensors. It allows only 3,520 of those same particles. That is 100 times cleaner. The air in these rooms, it's controlled to a level that is just near absolute perfection. And what's the biggest threat to that perfection? It's us, our bodies. Remember that natural, healthy process we talked about, desquamation, the shedding of skin cells? Well, in here, that becomes the number one enemy. A single invisible flake of skin could short circuit a microchip. It could contaminate an entire batch of vaccines. It could make a satellite completely fail once it's in orbit. So what we're left with are two completely opposite, yet equally vital strategies for survival. On one side, you've got shedding. That's the strategy for resilience, right? You sacrifice a part to save the whole, you embrace change and renewal. Then, on the other side, you have containing, and that's the strategy for perfection. You protect the whole system from the tiniest little part, and you do it by enforcing absolute, total control. And all this brings us to one final big thought. As we design more and more complex systems, I'm talking about everything from AI to entire cities, we face this fundamental choice. Do we build for resilience, allowing for things to fail gracefully and then renew themselves? Or do we build for perfection, trying to get absolute control where even the tiniest contamination is a catastrophe? Shedding or containing? The answer to that question might just define our future.